what I'd like to do here today is to walk us through an example of creating our own package in Java. And this kind of has two purposes to it. One is that we would like to factor out some common code that we've been seeing in a lot of our graphics animation programs. So there are two classes that keep coming up over and over that are very similar to each other. We've got the class that has the main method, and it creates an object with a run method, and that has a panel with a paint component method. And then that one tends to have a list of animated objects that we redraw. And then we have the animated objects themselves. So what we're going to do is create a couple of Java classes that try to factor out some of that common code and see how it can make specific applications a little bit simpler. And then we'll put those into a package. We'll start that process today. We'll see how to use it. And then on Monday or possibly in lab, we'll see how we can put those into what's called a jar file to be able to share it more easily among different projects. You've been writing code in Java for years, and every bit of code you've written most likely has been in the default package, or if it wasn't, it might not have been on purpose that you put it into another package. You might remember this keyword coming up if you were in lab and you typed touch package.bluej in the wrong spot, and you got all those go up buttons and things like that. We noticed that in your code, Bluej was trying to be helpful and put a bunch of package statements at the top of your programs that I made you remove. Well, today we're going to see how we would add those on purpose. Anyway, the project system basically lets us group classes together, just like a class groups together variables and methods. This would group together related classes that work together to solve some sort of a problem. As our programs get larger, we'll want to organize that way. So this example we're taking a look at, the threadgraphics package. You're welcome to clone it when you get a chance. You don't have to do it right away if you don't want to. But here it is. This is the repository for it. And the first thing we'll notice is that none of the code is sitting here at the top level of the repository. I put the code into a directory called source, SRC. You'll see that a lot if you look at packages that are out on GitHub and elsewhere. I think that's an artifact of people using Eclipse and maybe some other development environments that likes all of your code to be in source. But I'll use that model here. But we can see also within that source directory, we've got two other directories, the first of which is a pretty long path. Inside of source, there's edu/sienna/csis225/threadgraphics. And that's where these two classes we're going to be looking at live. And these, let me bring those up in Emacs here. So here's threadgraphics controller. And I'm going to bring up as a comparison, one of our recent examples. This is the ball tosser, that the ball bounces around off the walls and off the floor and off the ceiling. And this is the version that has the lock for synchronization implemented in it. So if we start by just looking at this guy, find the right window again here. If we start by looking at the ball tosser, we see that a lot of the code that's in here is repeated in many, many of our examples. So we tend to extend mouse adapter or something else for event handling. We implement runnable. We've got some variables that we see over and over. We've got a run method, and how many times have we copied and pasted this and just made some minor changes to it? We tend to create a panel with a paint component method, which has similar structure most of the time. We add some listeners, we create a list, and then we do these last couple of things to make things visible. Then we've got our mouse event handlers, and then finally they all tend to have a main method that looks kind of like this. So over here in our package that we're creating, we've got something that kind of looks like that. So we've got some instance variables, we've got one of these locks, we've got a constructor that's new, we've got a run method that looks kind of like the run methods we've been dealing with. And then there are a few others down here. And we'll take a look at each of these as we go forward. So the first thing we can see here that's different is that I do have a package statement at the top of my program. And that package statement is using the standard way of naming packages in Java. What you're supposed to do is take the domain, your internet domain of whatever organization produced this code, and you reverse it. So I'm pretending there's a csis225.siena.edu. So I reverse those, and then I put the name of the package that I'd like to create in that directory. And that matches what we saw in the repository. And over here, I have a clone of this repository. So if I'm in the source directory and I go to edu/siena/csis225/threadgraphics, that's where I'm going to find my code. And that path should match the package description up here. I've also gotten rid of my wildcard imports and just imported the things we're actually using in this case. Okay. Please stop me at any time here if you have any questions. That goes all the time, but making sure that you remember that. So the first thing is we want to think about the common functionality among things like the ball tosser and the falling snow and all these other examples where the bubble blower, where we have a class that looks like this. What are the things that kept coming up over and over and over? Well, they all implement runnable. So I'm going to have my class here implement runnable. Many of them would have a list of objects. Well, each one would have a list of a different type of object. So we replace this with falling ball or falling snow or cloud or gravity ball or whatever, bubble. But we're going to have our second class over here in the package be an abstract class that anybody who wants to be your animated object should extend that abstract class. So we're going to call these animated graphics objects. And we also always have this panel. So I've got my panel here in the new class. And both of these are now declared as protected instead of private. So when I extend this class, I have access to them in the derived classes. These are a couple of new variables here that we'll take a look at in a second. We introduced this lock about a week and a half ago when we fixed the synchronization of this particular example. And again, we'll get back to this new instance variable here in just a minute. But then there are other things like the name constant for the sling factor, some instance variables that deal with feedback for mouse pressing and dragging and all that. Those are very specific to the ball tosser example. So I can't put those in this generic version over here. Also, by the way, if you wanted to follow along with what I'm saying, I'm basically going through the notes here today and going through the bullet items. So if you wanted to go back, you can take a look at that later on. All right. So let me get next to the constructor. So we didn't have a constructor over here in ball tosser. We just relied on the default constructor. So if I go to the bottom in my main method, all of our programs say new ball tosser or new whatever. And since we pass it to this invoke later, it ends up creating a thread and calling our run method. In our general case, we needed a little bit of additional information for that run method. A couple of the things that the run method needs are what is the name of the window and how big should it be? And that's why we've introduced a constructor over here in the generic class. I need to pass that information into the constructor. What should I label my window? How big should I make it? And then I'm going to store it in these, scrolling the wrong way, store it in these new instance variables that I just created. That means when somebody is going to construct one of these thread graphics controller objects, they're going to be a derived class, they'll have to make sure they call this constructor with the appropriate parameters. And we'll see that when we look at how ball tosser got modified to use this.